Yes, sir.
Yes, sir.
Hey,
Yes,
hola.
yes,
Yes.
sir.
Now,
Yes, sir.
welcome to the third day of myself teaching you organic chemistry chapter 8. Okay,
Kota.
today is 27th of August 2021, and in my yesterday's class, I was talking about homologous series. I explained you the homologous series alkanes and what? Alkanes and alkenes. Okay,
Alkenes.
alkanes and alkenes.
Alkynes.
I've explained in yesterday's class, in the previous class. Today, I'll explain you the third homologous series of hydrocarbons, which is called alkynes, which is called alkynes. Please mute yourself. I can hear somebody's parent shouting over there. Please mute yourself and listen only. I can hear somebody's parent
Oy,
shouting.
Ankit, mute mo.
Ankit Kal.
Ankit Kalakote.
Okay, now let us come back to alkynes. Alkynes. Alkynes are the third. Alkynes are the third homologous series of hydrocarbons. Now, talking about alkynes, in alkynes you will find at least one. You will find at least one carbon carbon triple bond. Carbon carbon triple bond. And alkynes, they they have a general formula. They have a general formula CnH2n minus 2. This is the general formula of alkyne, where n will be equal to either 1, 2, and so on. Okay. Now let us draw and write down the molecular formula and structural formula of some alkynes. Now the first one, when n is equal to 1, when n is equal to 1, the alkyne will be C1H0. This is not possible. Okay, this is not possible. So this is not the first alkyne. Now when n is equal to 2, then we will have, if you put the value of n is equal to 2 in the above formula over here, you get C2H 2 to the 4 minus 2 is 2. So this is the molecular formula of the first alkyne, which is called ethyne. The nickname of this ethyne is acetylene. 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 Nickname. This is the nickname. Okay. The correct name is ethyne. Now, looking at the structural formula of ethyne, we put two carbon atoms side by side and put a triple bond between the two carbon atoms. Okay, put a triple bond like this, and for each carbon we will put one hydrogen to satisfy the valency 4. One bond, this is one single bond, 2, 3, and 4. So the valency of each carbon is satisfied. On the other side, we put hydrogen for this carbon also. So the valency of this carbon is also satisfied. 1, 2,
Sir, excuse
3,
me,
and
sir.
4. Yes.
Sir, silicon is a metalloid, no?
Yeah, silicon is a metalloid.
Which has valency 4. And why not carbon is metalloid? It's non-metal. Why?
It is non-metal because it doesn't have higher orbitals. No? It has orbitals less than electrons less than 8. Its maximum number of electrons in its valence shell is only 4, and total number of electrons is 6. And higher orbitals are not available in the case of carbon for it to behave like a metalloid. That means show non-metallic properties also. Am I clear? Am I clear?
So can you repeat it? Sir, can you repeat again? I did not understand. So the dog was barking.
And that's why I'm saying mute yourself and then you listen carefully. Okay. Carbon, it has small size. Carbon has small size because its atomic number is 6 and it has only 4 electrons in its valence shell. Whereas silicon its atomic number is 14 and comparatively size is bigger. Okay, and for silicon, higher atomic orbitals are available. That is why it shows properties of metals also, it shows properties of non-metals also. Whichever element,
which
whichever,
means,
yes,
which means that size matters. No, sorry, if the
yeah,
atomic size is more than.
size, yeah, size matters, and the number of electrons available, higher orbitals or what you call shells also matters for an element to show both metallic and non-metallic properties. Are you getting it? Are you getting it?
Yes, sir.
Yes. So I'll just give you an example. When you are in class 10A, okay, you are in class 10A, no, Dakshis? No, 10B. Dakshis, which section are you in? Class 10A or 10B?
10B.
Okay, 10B.
B,
Now,
B.
during your Nepali class, when it is offline classes, regular classes in the school, which class do you go to?
Section C.
You go to section C. So, to enter section C, do you need to come out of the door and fall in the
Yes,
corridor over
sir.
there and then go to section C? So, in a similar way,
Yes, sir.
along the periodic table, across the period, when you move from left towards the right, the metallic character decreases, and we get what you call metalloid in between, and then there are non-metals after that. Okay, in a similar way, here also, carbon belonging to the same group as well as silicon, the size is affecting, the availability of higher shells, higher orbitals is affecting that element to behave as a metal or a non-metal or a metalloid. Am I clear? Am I clear?
Yes, sir.
Now,
Now,
now it is very
very
clear. Now, listen. My dear students, it is a request from my side, okay, that when I'm teaching, focus on what I'm teaching. Don't wander your mind here and there. When I'm teaching chemistry, focus on chemistry only. Okay, don't wander on biology. Okay, because that question which you asked over here, Dakshis, he asked me a very good question, but that question is irrelevant. It is irrelevant. It is not related anywhere. Okay, if you are in a court of justice, then you will be banned over there, banned from entering the court also. That's why ask relevant questions. Ask questions related to, just now I'm teaching you ethyne. I'm trying to show you the molecular formula and the structural formula of ethyne. That is why your question should be based over here only, not beyond this. Because it is very important to stay yourself focused. Focus on what is being taught and try to understand. That's why you are the first person always after the class to come up with whatever I've taught in the class. Are you getting it? That's why you be where you are. Okay, now this was the third homologous series of hydrocarbons, which is called alkynes, and I've written down the molecular formula of ethyne, which is nicknamed as acetylene. The structural formula is here. The structural formula of ethyne is here. You can see. Now, whenever it is an ethyne or an alkyne, you have to make sure that each carbon atom must have four bonds. Each carbon atom must have four bonds around it, to satisfy the tetracovalency. To satisfy the tetracovalency. Now, moving to the next slide. Let me show you or give you some more examples over here. Okay, some more examples for this. Okay, now some more examples. For alkynes, if I put the value of n is equal to 3 in the formula CnH2n minus 2. This is the general formula of alkynes, homologous series. Okay, now let me put the value of 3, so it becomes C3. H becomes 3 to the 6 minus 2 is how much? 3 to the 6 minus 2 is how much? Speak now. When I
4.
tell to speak, you speak.
4.
It is 4.
4.
Yes. Now, this is the molecular formula. This is the molecular formula of the alkyne. It is the molecular formula
propine.
of the alkyne, which is called propine. It is called propine. Propyne. Propine. Okay, molecular formula. Now let us draw the structural formula. Now for the structural formula, I will draw the skeleton. Carbon, another carbon, another carbon and link them with first single bond. But since it is an alkyne, alkynes, I have told you, they contain at least one carbon carbon triple bond. So I can put the triple bond here. I can put the triple bond in the between the first and the second carbon also, like this. Carbon, carbon, carbon. I can put the triple bond here also. Anywhere I put it is the same thing. They should have at least one carbon carbon triple bond. After putting the relevant required bonds wherever necessary, now I will give hydrogens to each of the carbon atoms. This carbon which you see, it will need three hydrogens, one here, and one here. This carbon, the second carbon, the central carbon over here, the second carbon, it already has four bonds. It already has four bonds. So its valency is already satisfied. Its valency 4, it is already satisfied. So it does not need any hydrogen. Okay, so no need to put hydrogen over here. Then look at the third carbon. The third carbon has one bond, two bond, three bond. It is short of one more bond. So on the other side, I put one hydrogen. So that is the structural formula of the alkyne, which is called propyne, containing three carbon atoms. Okay. Now the same thing I'll explain here also. This example, this structure. This carbon has three bonds already, so it needs one more bond. So I give one hydrogen over here. The second carbon has already 1, 2, 3, 4 bonds, so no need to give any hydrogen. The third carbon has only one bond. It has only one bond, so I need to give it three hydrogens like this. So that satisfies the valency of all the carbon atoms in this alkyne, this propyne. So this is the structural formula of the alkyne, which is called propyne. Both are same. Both are what? Same. Both are same. Are you getting it? Am I clear with this homologous series alkyne example propyne? Am I clear?
Yes, sir.
Okay, very good. Now I move to the next slide to give you some more examples with regard to this alkynes, the third homologous series of hydrocarbons. Okay. So on your screen you can see the next example when n is equal to 4 now. 4. I'm putting the formula value of n is equal to 4 in the general formula CnH 2n minus 2. These are all alkynes. These are all alkynes. Okay, now 4 carbon atoms. N is equal to 4. So I first draw the carbon atoms. A skeleton, carbon 1, carbon 2, carbon 3, carbon 4. Okay, am I clear? Am I clear, all of you? Now we know that
Yes, sir.
it's an alkyne, so I need to have at least one carbon carbon triple bond. I can put the triple bond here. Okay, I can put the triple bond here. I can put the triple bond here. All possible things are there. These are the three possibilities of putting the triple bond between two carbon atoms. Now I must give hydrogens to the respective carbon atoms. Now if you look at the first one over here, this carbon has three bonds already. It needs one more bond, so I give one hydrogen over here. The second carbon already has 1, 2, 3, and 4 bonds, so no need to give any hydrogen. The third carbon has two bonds on either side, so I need to give two more hydrogen over here, this way. The fourth carbon has one bond, so I need to give three more hydrogens to satisfy its valency. So this is the structural formula of the alkyne, whose name is butane. Butyne. Butane. It is what? Butane. What is it? Speak, all of you. It is called butane. What is it called?
Butane.
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 Butane. Yes.
Butane.
Okay. You'll be loving these names.
Butane.
You'll be loving these names. Okay. So
Yes, sir.
later on, when you marry and have children, no, make sure you name your children as either alkane or methane or butane or propyne. Okay. Don't name propyne. Huh? Now, after that, look at the second example over here. This one. The second one, this carbon has only one bond, so I have to give it 3 hydrogens. This carbon, it has already 1, 2, 3, 4 bonds, so no need to give any hydrogen. This carbon also already has 4 bonds, 1, 2, 3, 4, so no need to give any hydrogen here also. The last carbon, it has one bond only, so I have to give it 1, 2, and 3 hydrogen. So this is also butane. This one is also butane. This one is also butane. But what is different in these two? Tell me. What is difference in this structure and this structure?
Chemicals.
So there are two carbons which are satisfied.
No, no. What is the difference in this structure 1 and structure 2? Tell me. What is different? Let me know.
Structural
Places of
formula is
hydrogen is
different.
different.
Huh?
Hydrogen places are different.
Yeah, no, no,
Hydrogen
not,
places
not
are
hydrogen, not hydrogen, not hydrogen. The position of something is different. The position of the
Carbon.
triple
The
bond.
triple bond.
Yes, the position of the
Triple
triple bond here, in this case, it is between first carbon and second carbon. In this second example, the position of triple bond is between second carbon and third carbon. So, these two, my dear boys, they are called isomers.
Isomers.
Isomers. They have the same, what? They have the same, what do you call?
Molecular
Molecular
formula.
formula, but their
Chemical
structural,
formula
but the
and
structural
molecular
formula
formula.
is different. But the structural formula is different. So, my question is, do alkynes show isomerism? Do
Yes, sir.
alkynes show? Yes, they will
Yes,
show.
sir.
They will show position
After butane.
isomerism. They will show position
So
isomerism. They will also show chain isomerism. It is possible to branch them
Excuse me,
as well.
sir.
Yes.
Excuse me, sir.
Yes.
So does alkyne, the propine, no, sir, propine,
Yeah.
does it show isomerism?
Propine. Yeah, it will not show isomerism. More than 3. From butane onwards, isomerism is possible. From 4 carbon atoms, isomerism is possible. That I have told you already in the previous class. Whenever it is
Okay.
carbon equal to 4 and more than 4, then only isomerism is possible for alkenes and alkynes. Alkenes containing double bond, carbon-carbon double bond, and alkynes containing carbon-carbon triple bond. Am I clear? Am I clear? Okay.
Yes, sir.
Now,
yes,
Yes, sir.
now
Yes,
let
sir.
us
Yes, sir.
let us move to the next slide. Let us move to the next slide very happily. Okay, now let us take one more example for n is equal to 5. How much? 5. N is equal to 5. And put this value of n is equal to 5 in this formula. CnH2n minus 2. Now, this is also a general formula of alkyne. Okay, now I'll put the value of n is equal to 5. I will get molecular formula C5H how much? C5H how much? 5 to the 10 minus 2 is 8. 8. Very good. So this molecular formula is the molecular formula for pentine. Pentine. Pentyne. Pentine. Am I clear? It is the molecular formula for pentine. Now let me draw the structural formula. Okay. So here we are with the structural formula. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. Okay. Now in this example, I'll put the triple bond in the first and the second carbon. Okay. Another example. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. So here I'll put the triple bond in the second and third carbon. Another example. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. Here I'll put the triple bond in the third and the fourth carbon. One more I can put over here. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. Here I'll put the triple bond in the fourth and the fifth carbon. Am I clear? Am I clear?
Yes, sir.
Yes, sir.
Yes,
sir.
Now,
Yes, sir.
now let us
Yes,
let us
sir.
give hydrogens to the respective examples. This is number 1. This is number 2. This is number 3. This is number 4. Okay. Now I'll give the hydrogens to them. The first one, this carbon needs only one hydrogen. This carbon doesn't need any hydrogen because there are already 4 bonds around it. This carbon needs 2 hydrogen. One here, one here. This carbon needs 2 hydrogens, one here, one here. This carbon needs 3 hydrogens, one here, and one here. Now count the number of hydrogens total in number 1. How much?
8. 8.
So
Eight.
is it obeying this formula? Is it obeying?
Sir.
Yes,
Yes,
sir.
Now
Yes,
similarly,
Yes,
the second one also I'll give the hydrogens. This carbon, I will give 3 hydrogens. 1, 2, 3. This carbon I will not give any hydrogen because it already has 4 bonds. This carbon I'll not give any hydrogen because it already has 4 bonds. This carbon I'll give 2 hydrogen, one over here, one over here. And the last carbon I'll give 3 hydrogens, one here, and one here. Now count the total number of hydrogens.
8.
Is it
8.
8? Are we correct?
Isomerism.
Are we correct? So are
Yes,
these
sir.
two isomers?
Of
Yes,
course.
Are these
Yes, sir,
two
isomers.
isomers? Okay, let's go to the third one.
Sir.
Let's look at the third one. Okay. Now look at the third one. The first carbon, it needs 3 hydrogen. 1, 2, 3. The second carbon needs again 2 hydrogen. 1, 1. The third carbon doesn't need any hydrogen. Okay. The fourth carbon doesn't need any hydrogen. It already has 4 bonds. And the last carbon needs 3 hydrogen. Now count the total number of hydrogen. Is it 8? Is it coming to 8? Is it obeying this? Okay. So now this number 1, number 2, and number 3. Are these 3 isomers? Are these 3
Yes,
isomers?
sir.
Are these 3 isomers? Yes.
sir.
Yes. Now look at the fourth one. Fourth one. Carbon 1, I'll give 3 hydrogen. Carbon 2, I'll give 2 hydrogen. Carbon 3, I'll give 2 hydrogen. Carbon 4, I'll not give any hydrogen. But carbon 5, I'll give 1 hydrogen. Now count the total number of hydrogen. Is it coming to 8?
Eight.
Yes, it is coming to 8.
8.
So now, don't you think
Yes, sir, 8.
this structure and this structure is same? Just see,
Yes, sir.
it is same.
Yes, sir.
It is same. It is same because I am holding it
Yes,
here
sir.
and
Yes, sir.
I am holding it here and turning it upside down. The other,
Yes.
I am holding it here and catching that
Yes, sir.
hydrogen over here and turning it and taking this hydrogen the other side. This will come this way and rotate one down. Structure 4 and structure 1 is same. Okay, so how many isomers are possible for pentine position isomers? How many?
2 I.
No, it's not 2,
Two.
3. 3. 1,
3.
2, and 3. Fourth isomer is not possible because the fourth one and the first one is same. Because the fourth one and the first one is same. So the isomers possible are 1, 2, and 3 only. Am I clear?
So
Yes,
1, 2, and
sir.
1, 2, and 3. 1, 2, and 3 are isomers.
So 1 and 4 are that equal.
They are same. They are the same thing. It is just turned the other way around. It's turned this way.
Yes, sir. But
Just catch
like
and,
this.
yeah.
Yeah.
Clear?
Only 2 isomers possible. No, then
No, only 3 isomers, not 2 isomers. 3 isomers are possible. 3 isomers. Because 1 is not equal to 2, 2 is not equal to 3. Watch carefully now. You have eyes. Where one more eyes over there? Watch carefully. In first one, the triple bond is between first carbon and second carbon. In the second one, triple bond between second and third carbon. In the third one, between third and fourth carbon. These 3 are different. Structural formula is different. That is why they are isomers, but the molecular formula is same. Am I clear? Am I clear now?
Yes, sir.
You need,
Yes, sir.
you need to spend some time.
sir.
Okay, now let us move further. Let us move further for today's class. Okay. Now I have made it very clear for you all about alkanes, alkenes, and alkynes with regard to what? With regard to homologous series of hydrocarbons. Alkanes, they show isomers, chain isomers only. Alkenes and alkynes, they also show isomers, both position and chain isomers. You just know you saw chain isomers, what you call position isomers. These are all position isomers. These are all what? Position isomers, three of them. Because the position of the triple bond is changing. It is shifting from first, second carbon to second, third carbon to third and fourth carbon. That is position isomers. If you go for higher alkynes, then there is some possibility of showing exhibiting chain isomers as well. Now look at the next slide. Okay, homologous series. Now, homologous series definition, it is a family of organic compounds. It is a family of organic compounds which possess certain common features. Okay. Now, the successive members differ by a CH2 group. Members of a series can be represented by the same general formula. Members show a gradation in physical properties. Members have similar chemical properties. So these are some points, important features of the homologous series. Now, let me explain this to you all, okay, with the help of the next slide. Now look at your screen. Look at your screen. Now, I am drawing lines on the screen. Can you see the lines? Yes, can you see the lines on the screen?
Yes, sir.
Okay.
Yes,
These lines are very, very straight, isn't it?
sir.
Are these lines very straight?
No,
Yes,
sir.
sir.
No,
Most
sir.
important.
Who is saying yes?
We can see.
You can
Yes,
see
sir.
Is it very, very straight? Are the lines very, very straight?
No, sir. It is not
They are
so.
not
Sir,
straight.
not very great
No,
lines.
sir.
Not
Yes.
very
Sir.
great
Yes,
lines.
Yes. Now I'm going to draw lines again.
Yes, sir.
Slightly. If I put effort, I can do things better. So
Yes, sir.
I'm trying to make three lines on the screen. Two lines on the screen. Two lines means I have made three columns. Column 1, column 2, column 3. Okay. How many columns on your screen? How many columns on your
Three.
screen? Three columns. Good.
Three.
Now,
Three columns.
three
One.
columns. Wonderful. Wonderful.
Zeros.
There are three columns on your screen. Now, the first column, I will give it to the homologous series alkanes. I will give it to the homologous series alkanes. The second column, I'll give it to the homologous series alkenes. Alkenes. The third column, I'll give it to the homologous series alkynes. Alkynes. Is that clear, my dear boys? Now,
Yes, sir.
in these three words,
Yes, sir.
look at this part carefully. Whenever it is alkanes, A and E, there is A over here. There is A, no? Here it is E, no? Here it is Y, no?
Yes, sir. Yes, sir.
A means
Yes,
Yes,
sir.
sir. Yes, sir.
all single bond.
Yes, sir.
All single bond. In alkanes, there is A means in alkanes there will be all carbon-carbon single bonds. In alkenes, there is an E, so there will be all at least one carbon-carbon double bond. At least one carbon-carbon double bond. In alkanes, all carbon-carbon single bonds. And in alkynes, there is a Y, no, which means at least one carbon-carbon triple bond is there. One carbon-carbon triple bond is there. Am I clear? Am I clear, my dear boys? Am I
Yes,
clear?
Yes,
Okay.
sir.
Now,
Yes, sir.
alkenes and alkynes, what are these called together? What are these three called together?
Alkaline.
No.
Homologous series.
Homologous series.
Open chain
These are called
compounds.
homologous series for hydrocarbons. Homologous series for hydrocarbons. Am I clear? These are called homologous series for hydrocarbons. Now, what is the general formula of alkenes? CnH 2n plus 2. Alkene general formula is CnH 2n minus 2. Alkyne general formula is CnH 2n. Now, if I put the value of n is equal to 1 here, I will get CH4. Here I will get CH2. This is not
So
possible.
you did a mistake, sir.
Where?
H2N-2 is
Oh,
alkynes.
oh, sorry. Just a second. Let me do the correction. Okay. See, very good boy. So this one is wrong. Okay. Now here it will be excellent. So 2n minus 2. Correct. Now here if I put the value of n equal to 1, I'll get CnH0. This is also not possible. This CH4 is called methane. It is called methane. Okay. Next one, value of n is equal to 2, I will get C2H6. This is called ethane. A-N-E, ethane. If I put the value of n is equal to 2, I'll get C2H4. This is called ethene. E-N-E. If I put the value of n is equal to 2, I will get C2H2. This is called ethyne. It is called ethyne. Again, moving further down, C3H, 3 to 6 plus 2, 8. This is called propane. All the alkanes, do you see they having N's at the end? Here C3H6. This will be called eth. This is not eth, sorry. Just a second. It is called propene. Here if I put the value of n equal to 3, I'll get C3H, 6 minus 2 is 8. This is called, how much is it? Is it 8? 3 to the 6, 6 minus 2 is 4. This is 4, sorry, mathematically. Okay, C3H4. This is called propyne. Okay, the third alkyne. Then here if I put C4H, 4 to the 8 plus 2 is 10. This is called butane. If I put over here 4, C4H8. This is called butene. If I put over here C4H, 4 to the 8, 8 minus 2 is 6. This is called butane. Last one, C5H12.
Okay.
This is called pentane. A-N-E. All of them N. Over here, C5H10. This is called pentene. Pentene. The next one over here on the alkynes, if I put value of n is equal to 5, C5H, 5 to the 10 minus 2 is how much? 8. This is called pentyne. Am I clear, boys? So this is how you derive the molecular formula. This is how we derive the molecular formula of the corresponding homologous series, whether it is alkanes or alkenes or alkynes, by strictly using their respective formula. Am I clear? I think it is already time up.
Yes,
That's why
yes,
I'd like to end my class here only, but don't bunk, okay? Wait over there because I need to record your attendance. Without
Thank you,
attendance, life is not possible. Do not thank me beforehand. Wait.
Thank you, sir.
Wait. Let me record the attendance. Then only you will leave the class. Otherwise, you will be marked
sir.
absent. Okay.
Okay, sir.
Yes, you are all good.
Okay, sir.
Okay, sir. Okay, sir.
Okay, attendance is being downloading. It is downloading.
Yes, sir.
Downloading. Wait.
So we can go.
It is downloaded. Now you can go. Thank you so much. Have a nice day.
Bye, sir.
Thank you.